Now, the 2025 paper JE means for the chapter motion restraint straight line. The second topic, which is non-uniform motion, I found uh, I'm not sure how to put this in words, but maybe like a new trend, unlike in the recent years. Now, this is one classic example of you know um, JEE means, for that matter, almost every exam that's conducted in India, that they tend to extrapolate what is given in the previous year questions or in the options or definitely in a related concept. And therefore, the significance of we going through each and every option, each and every associated concept, to prepare ourselves for surprises like this. What do I mean? See, this question here is actually based on average velocity. Average velocity mean, if you see, it's primarily based on average velocity and instantaneous velocity. But then let's have a look at what kind of questions were asked in the recent past. So we have uh okay, I'm not having the question the years properly here. But anyway, this all these questions will definitely from 2020 to 2024. Okay. So what do we have here? Area under area under the velocity time graph, right? Area under the acceleration time graph. So the JE mains is telling you, see, if you're preparing for the JE mains, then go through graphs in chapter one: velocity time graph, acceleration time graph. And having said these two, definitely the case which should be what? Let's write it down. Write it down. This. So we have velocity time graph here and acceleration time graph. So definitely we will have to prepare ourselves for the position or the displacement or the distance time graph, which exactly was the question in 2025. I hope that makes sense, right? See, let's go to another question. 2023 again. What we have here is velocity time graph. 2023 velocity time graph. 2025 displacement time graph. Okay. Now, another one here, the velocity time graph, the total distance covered by it is, which is again area under the curve. Interesting question. XT graph and the corresponding VT graph. I would say these are the conceptual questions. These are the ones that makes, the JE means defined. I mean, the standard questions, I would say. Let's have a look at other question as well. Again, 2021. What do we have here? Constant acceleration, v square versus x graph. So v square versus x. This again was I wouldn't say a challenging question, but not definitely not easy. Okay. So if you look at the plot, I think this was in 2021, 2022, if I'm correct. So velocity, time graph again, right? So velocity, time again. And look at what we've been asked to find out of it. Ratio of displacement to distance traveled from a velocity time graph. So the point is, it is not the direct answer or direct numerical that JEE means is nowadays trying to, it's kind of evolving from its give a question, give some values, and then ask the student to kind of, apply equation and then come out with the answer. No, it is rather asking you how do you or how much deep do you understand about the concepts behind this. And the most important tool that is used to verify and to validate laws of physics is experimentation, the observations which are tabulated and then are analyzed using a graph, right? And therefore this graph becomes really important because see, If you know how to find the ratio of displacement and distance traveled by a VT graph, it simply means that you know the concept. So that's what the J means is trying to figure out here. Okay. Now, having said this, let's try to come back to the question and understand what this is about. Okay. So we will go through these topics, okay, which is meaning of slope, slope of chord or a secant line of a tangent, and then how to calculate average velocity and instant velocity from the graph. Yes, it would be good if you can make a note of this and then expand each point here. So, in simple terms, what is slope? Slope is basically how steep a line is, which is mathematically written as rise by run, or change in vertical by change in horizontal. Okay. If the vertical axis is y and the horizontal axis is x, slope is y2 minus y1. Now this actually stands better to write it like this. So this is x1 comma, my bad, x1 comma y1, and this point here is x2 comma y2. Therefore, what is rise? Rise is therefore y2 minus y1. And what is run? Run is x2 minus x1. And the ratio of y2 minus y1 rise by x2 minus x1 run gives us a slope. Okay. Now, my bad. Okay. Now, what's a chord? See, a chord or a secant line is a straight line joining 2 points on a curve. So we have a curve here. There are 2 points, point A and point B. A straight line joining these 2 points is a chord or a secant. How do we draw a secant? You pick point A, point B, join A and B, join A and B, and the slope of this curve gives the average velocity. I'm sorry, the slope of this chord gives us the average velocity. Okay, which means if you calculate the run here from say x1 y1 to say x2 y2, what is the run here? The run here is x2 minus x1, right? And what is the rise here? The rise here is y2 minus y1. And slope, which is m, of AB, which is the chord, is equal to y2 minus y1 divided by x2 minus x1, which is what gives us the average velocity. Okay. Now we discussed slope. What is chord? What is tangent now? Tangent is a straight line that touches the curve at one point and matches the curve's direction there. To calculate the slope of the tangent, you still use 2 points, but those 2 points are chosen on the tangent line, not necessarily on the curve. Okay, which means, let's say, no, don't worry, I do have better graphs that will make you understand this. For the time being, just follow this. So we have the y axis here, right? And let's say we have the x axis here like this. Okay. And say this is the point here. This is not P. This point here is P. And this line here, this straight line here, let us call that as line as AB, right? That line is called as the tangent. And if you plot 2 points there, maybe like this, if you plot 2 points there, then calculate the run and the corresponding rise, what you get is slope of tangent, which gives us instantaneous velocity at the point where the tangent is drawn, which is at this point at t. So, slope of AB, which is the tangent, what does it gives us? It gives us the instantaneous velocity at the point P. Okay. Okay. Now, how do we find the slope of a tangent? Draw the tangent at this point. Pick two far points in the tangent. Maybe say, okay, we just saw this in detail, right? Okay. And what is the slope of the tangent at that time t0? It is the instantaneous velocity at t0. Okay. Now, if you have not writing things along with me so far, please make sure to write it down at least now. So it means that on a graph, if you find the slope of a chord, use 2 points on the curve, what you get is the average change over an interval or the average velocity between these two times. Instead, if you use at one instant, use the direction at single point and use 2 points on the line. Maybe I should write it down here. Here as well, you can use 2 points, but not on the curve, rather on the tangent. What you get is slope of the tangent, which gives us the instantaneous velocity at a specific time. So this is between time t is equal to 4 to time t is equal to 8, say for example. Whereas this one will give you the exact velocity at time t is equal to 12 seconds. Okay. Now, a small calculation on this average velocity. Say we have t1 is equal to 2 and the corresponding x1 as 5. T2 is equal to 6 and the corresponding displacement as 25. What is x2 minus x1? 25 minus 5. What is T2 minus T1? 6 minus 2, which is 4. 20 by 4, which gives us 5. Therefore, the average velocity is 5 meters per second, which means if you measure it from T1 to T2, the object has traveled at least 5 meters in 1 second, the average. Okay. Let's now visualize this calculation on a graph. The same calculation. Let's look at this. So we have the point here. this is x1 comma t1, and b here is x2 comma x2 comma t2, right? What is the run here? The run here will be equal to t2 minus t1, which I have written as delta t here, which is 6 minus 2 equal to 4 seconds. What is the rise here? It is x2 minus x1, which is, what is x2? Oh, I think the coordinates are written in an incorrect way. My bad. x2 should be x2 should be 25, right? So 25 minus 5, which is 25 minus 5, which is 20, and delta t is 40. Therefore, 20 by 40 is 5 meter per second. And what is this equal to? This is equal to the average velocity. So we just saw the way to do this question. Not the question, the calculation of average velocity using given tabular values and using a graph, right? So now what we'll do is we will do the same calculation for exactly for tangent, which will give us instantaneous velocity. And what does the calculation look like? So what we have here is a function x of t is equal to 2t square. Velocity gives dx by dt, which is 4t. So at t is equal to 3 seconds, velocity is 4 times t, which is 3, 4 times 3, which is 12 meter per second. Let us now try to visualize this. Okay, maybe just write it down one more time. So what is x is equal to? X is equal to 2t square. What is v? It is d by dt of x, which is d by dt of 2t square, which is therefore equal to 2 times 2 times t to the power 2 minus 1, which is 4t to the power 1, or 4t. And when t is equal to 3, what we get is 4 into 3, which is equal to 12. Okay. Now let's visualize the same thing on a graph. This is what we see. We have a graph here, a parabolic curve. We choose a point A. What is A? A corresponds to the point that we just made a note. A is actually the point which corresponds to the physical description of displacement at t is equal to 3 seconds. Okay. And what is the corresponding displacement? The corresponding displacement is 18 meters. Why? Let's see. What is x is equal to? X is here equal to 2t square. What is t? T is t, 3. So this is 3 square. 2 into 3 square is 2 into 9, which is equal, therefore x is equal to 18 meters. Now, if you draw a tangent along A, sorry, a tangent at A, if you draw a tangent at A like this, tangent at A, and then find the slope of this tangent by selecting 2 points. Let us take 2 points here. Maybe these 2 points. Let's say the easiest one here would be starting from this point and say this here. Okay, and let me write this as the points BC. What is the rise? What is the run for BC? This point, this length here, BD, BD to DS, right? What is the measure of BD? So if you see here, BD is 1 unit along the y-axis. BD is 1 unit along the y-axis, which is 1 second. What is DC? DC is 1 unit, which is this much, plus some of it, right? Maybe less than half of it. What is 1 unit? 20 to 30 is 1 unit, which is 10, which is 10 plus, uh, I don't have the subsection here. Maybe this is less than half. So approximately 2, which gives us 12. So if you write down here, let me just clear this out now because we need only, oh, okay, maybe we need both of them. So what is slope of BC? Slope of BC is actually DC divided by PD, which gives us 12 divided by 1, which is equal to 12. When X, oops, my bad. Okay, so when we have X is equal to 18 meters, right? When X is equal to 18 meters, at time t is equal to 3 seconds, what is the corresponding displacement? It is 18 meters. And what is the velocity at that instant? It is corresponding 12 meter per second. How do we get this? We draw a tangent at A and then find the slope of the tangent, which gives us 12 meter per second. Yes, see, I do understand that it's taking a lot of time for this. But then the actual question here is, do we know to plot the displacement, plot the average velocity and instantaneous velocity from a graph? Because trust me, every chapter will have at least a question, at least a topic, which is more easy to understand if you apply graphs, which is more easy to solve problems if you know how to find out the slope from the graph. And most importantly, there are some questions that we are going to solve in the coming Irido series, which will start as soon as our first topic is over for the preparation of course, J Advanced, which is classic based on graphs. And then you'll have to do this on your own in many times exclusively for graphs. And then you'll be like, how do we get to this? So to avoid the confusion for the preparation of J Advanced, I'm just trying to take you through the basics of this, trying to make you calculate these things at least 3 to 4 times so that you just understand how to find the slope, how to find the slope of a tangent and that of a chord. Okay. Now, this is something that I don't want to do, I want to discuss here. But we have coming a couple of questions. Well, exactly. This is one of those questions that we will have to discuss in detail when we solve the Iridos. And I think it is exactly mostly similar to what we have here. Average from t is equal to 2 seconds to 4 seconds, and comparing that to a instantaneous velocity. So I'm not spending much time here. Let's focus on that later. But definitely, I would recommend that you pause the solution here and make a note of all these things. Okay. And also understand what is the meaning of this non-symmetric interval and velocity average not being equal to velocity instantaneous, because we will discuss this in detail when we come to the next set. Now, to summarize this, how do we plot slope on a graph for chord or a secant line? You first mark the points A and B, then join A and B with a straight line, then make a big right triangle on that line, and then calculate the slope, which is rise by run. Okay. Say if you have a graph like this, we have done this a couple of times. I'm just taking you through it one more time. So A, B, T1 X1, T2 X2. See, all of this comes from ChatGPT, and that's why some of them are the coordinates are written the wrong way. I should actually say this is x2 corresponding to t2y because it is x-axis as x. and y-axis, sorry, y-axis as x and x-axis as t. My bad. But anyway, you know what it is, right? So average velocity is delta x by delta t. This again is delta x by delta t for cot, right? And the same for what? Would be the same for tangent as well, which is put your ruler at the point, draw a tangent that touches the curve. Now pick two far points P and Q on that line, which is the tangent line. Read the coordinates of P and Q, and then find out slope is equal to yq minus yp by xp minus xp, which is y2 minus y1 by x2 minus x1. Okay. An example to visualize this. This again is this is not a correct representation. I would say we don't need this line here. Q, PQ, rise, sorry, run, rise, and velocity instantaneous is delta x by delta t, which is x2 minus x1 by t2 minus t1. Okay. So yes, please make a note of all these graphs, these tables. These are very important when it comes to understanding the subject. Now coming to our question, which is average velocity in the graph, something that we have been reading in the question, right? There are 3 to 4 statements, 4 of them which is based on average velocity, and one of them which is based on instantaneous velocity. Therefore, the reason why I took you through these concepts in detail, so that you can just apply these ones directly in here. Okay. Now, when we talk about average velocity, we can find out average velocity from the graph in many points, say from O to A, or could be from A to B, or A to C, or can be even from O to C directly, or could be from C to D, or from the starting point O to D, so on and so forth. Okay. So, how do we plot all this? AD, AE, how do we find these average velocities? Let's spend some time. So, what I'll do is you can find the rest of it. I will find, maybe we will solve it together, 2 to 3 of them, and then you will solve the rest average velocities on your own. Okay. And get back to me, most importantly. And if you come across something interesting, please share that. Okay.